So next up we have Lutz, who is currently the owner of OntoChem, but he's got over 25 years of industrial research. He's the co-founder of ChemAxon, Alphaptos, OntoChem, or he still is, Nexus Pharma, and MorphoChem. It's also very well published, over 80 papers, 10 book chapters, and he has 4 projects that are currently moving into clinical trials. Also, he got his PhD from the University of Leipzig.
So I'm very glad to be here again and to see the tremendous progress which has been made at ChemAxon. And I'm grateful to give you a talk about chemical ontologies, which is something we are involved with already several years at OntoChem. Now, you may know the term ontologies, you may know biological ontologies, but chemical ontologies are not really well distributed, or not really as much as in the head of the Cheminformatics Society as they should be, and therefore I'm happy to give a little bit of my thoughts about chemical ontologies. Now, chemistry has, of course, a long history in specialized databases, and this might be the reason why chemical ontologies have not been as much known so far, because chemists can search compounds, substructure searches, which is basically a kind of ontology search already. But there are some open needs which chemical ontologies could address. For example, smart chemistry search for non-chemists. So, for example, if a biologist wants to search for steroids, for example, and he doesn't know the structure, and he doesn't want to use chemical structure editors, then it's hard for him to do. Or other questions like lipids. So compound classes which don't have a common substructure, how do you search them? And on the other hand, taken together with other ontologies, you may ask high-level chemistry-related queries, and I would come back to this. So basically, chemical ontologies could bring chemistry closer to non-chemists. So for example, finding steroids, you would like also to find a compound which is this one, an insect steroid, actiosterone, for example. You may want to find lipids, so a term which is not really well defined in chemistry per se, in chemical structures. Or when you look at Marcus structures, like 1-cycloalkyl isoquinolines, that is a composition of 2, I would say, chemical ontology terms or structural terms. So what does cycloalkyl mean? It's not one structure, it could be several structures. And high-level queries could be what diseases could be treated with terpenes, which proteins are inhibited by terpenes, for example, or which steroids can I find in plants, which compound classes have antibacterial properties, or, for example, for drug repurposing, what are alternative uses of my compound class? So, chemical ontologies, what is the status today? Actually, it's not completely new. There are some chemical ontologies you're using, maybe without that you know that you're using chemical ontologies. This is actually in PubMed. They have, through the mesh terms, assigned compounds to compound classes. So, for example, you have the term steroids already in there, and you have compounds assigned to these classes, but this is done manually. And this is, of course, an error-prone thing, and it's very cumbersome. If you get a compound, you have to assign it to a compound class, and this is done by intensive labor. There's a new initiative, Chemical Entities of Biological Interest. That is currently the largest chemical ontology, comprises about 31,000 classes and compounds. The problem here is that compounds are integrated with the ontology and are not really well separated. And it's also done manually. And when you do something manually, you have, of course, some problems like you introduce redundant relationships, for example. You may miss relationships. You can have wrong relationships. And just to show you some examples of these from PubMed and Chebi, like redundant relationships, you have assigned threonine to the essential amino acids. Essential amino acids are assigned to amino acids, and then threonine is again assigned to amino acids. And this is redundant in terms of ontologies. And you can cause problems when you rearrange the ontology if you have these redundant relationships. Then you may have homonyms in the ontology, which is, for example, the case for mesh. Regular insulin is a synonym for regular pork insulin and insulin as such, which is, of course, not very nice. You have missing relationships. For example, histidine is not assigned to be an imidazole or carboxylic acid or an amine, and steroids are not assigned to be terpenes, for example. And there are even wrong relationships, like this bis-chlorophenyl ethanol being assigned to chlorohydrocarbons, which is obviously wrong. So when you start to think about ontologies, you have to think about design principles first. For example, how should the ontology be arranged? What kind of relationships should you have in the ontology? And in chemistry, there are some terms which are used for classes like derivatives, backbone, scaffold, compound class, and so on. And nobody knows exactly what this means, okay? There's no real common agreement how these terms are exactly defined. So you have to define these exactly. In Chemie, there are some additional relationships like conjugate base of or conjugate acid of, and I doubt whether a non-chemist would know what these things mean, okay? So a common understanding of terms is needed. So our intention was to build a chemical ontology editor with which everybody could build his own ontology and basically classify compounds into structural classes, like, for example, the steroids or terpenes, and which would allow the automatic assignment of compound classes, of compounds to compound classes, for example, in structure files or in databases. And also provide the other tools which you have in ontology editors, like loop detection, redundant link, homonyms, chemical validity and accessibility should be checked so that the ontology is nice. And also be optimized for named entity recognition in text. So, for example, make a difference between the term propane and propane derivatives. Because propane derivatives means in the text that it's not, we are not talking about propane, but something which is part of a molecule which contains a propane backbone or so. So just to show you two design principles we have introduced. One is the compound class. So a compound class, for example, cycloalkanes, according to the common understanding, cannot contain a halogen, for example. They cannot contain an aromatic ring. But a cycloalkane derivative, for example, could contain a chlorine. So there are these two major differences how a compound is viewed. And compound classes are also kind of defined by common understanding. So when you ask a chemist, what do you think a cycloalkane is? He has a certain understanding, and this needs to be programmed into this ontology. Now, just to show you this in a more complicated case, for example, androstane, which is on the left side, is basically a compound class which does not belong to pregnane. So although it would be a substructure of pregnane, it is a completely different compound class, has different biological functions, and therefore needs to be separated. So substructure search alone is not sufficient. And just to show you this, for example, androstanes and pregnanes are children of steroids. These are children of terpenes, prenolipids, lipids, organic compounds, for example. Now, how do we do this? Basically, we have said compounds are entities which can be described by smiles, and you all know smiles, of course. And compound classes may be described by smarts, which is also well known to the community here. You need to keep in mind that, for example, there are some classes which do not have a common substructure. In this case, this is defined through their children. So if the children have substructures, basically the parent knows what the structures are through their children. Okay, and in case of androstanes, this would look like this, that you have a fairly complex definition of androstanes. One, which gives you the stereochemistry, and one which gives you a smarts with different conditions, like for example atom lists. The problem is you can't mix stereochemistry with atom lists, because through the different atoms the stereochemistry may change, so you have to keep it separate. So you have a complex logic of smarts with and ORs, which are then built into our ontology and create this editor. And just to show you the editor itself, looks like this. So you have on the left side the chemical ontology. You can load different, for example, compounds. In this case, I have loaded the steroids from the Chebi ontology. And then you can assign these compounds with different compound classes. For example, this compound has been assigned to be a 5-beta cholane, which is in the hierarchy shown here. So you have a rather complex hierarchy tree of different chemical classes, and finally you have the beta cholane class, where this molecule is a children of or is assigned to this class. You have some structure checking here, which shows you which parts of the molecule match the class conditions, and yeah, basically you can rearrange these things back and forth in this ontology editor. It's also useful for other ontologies. You could also edit quite conventional other biological ontologies, for example. Okay, so using this, the program could read SMILES and different other file formats, also writes different file formats. Ontologies are based on smarts, integrates with name-to-structure tools, allows to edit and export OBO files, for example, and assigns compounds in files or databases. Now we have done this with PubChem, for example, and just to give you a picture of how many classes are assigned, is about each molecule is part of 10 chemical classes, approximately. You can use this also for assigning classes to text. Here you have an example of a scientific publication where you have different compound name classes, how to say. So we have, for example, a compound identified by ChemAxon's name-to-structure tool. We have compounds which are assigned by an anaphora resolution module. For example, this bold 4 is a compound which has been annotated to this bold 4 before. And we have compound classes like thioquinolines is a compound class, or 2-butenyl is a group which has to be attached to a scaffold. Okay. And some compounds are, of course, coming from a chemical dictionary, as you see in yellow. Now, just to give you an overview how this works as compared to current ontologies, like in PubMed. So typically, we see big differences that we can assign much more compounds and compound classes than it's currently done in PubMed. So, for example, some compounds, like heterocyclic compounds, which is a rather mysterious big class, you find very many compounds in PubMed. Okay. Not yet, thank you. I would like to show this in action. So, for example, in our query web page or demo web page, you can query monoterpenes, for example, on different. This one, for example, on Medline. And then you get, for example, with this general term monoterpenes, also cis-verbenol as a hit, which is of course true because it's a monoterpene. And basically we get all monoterpenes which are found with specific names in the text documents. You can also do now, so this is the example of annotating compounds and compound classes in text and using them. And just to show you an example of the higher level queries, for example, if you would like to know what monoterpenes are associated with, so for example, with diseases, so you could also use other ontologies we have, like biological effects, proteins, food and flavors, anatomy, or so on, but just search for diseases. So what kind of diseases are associated with monoterpenes, and using the US patents, okay? So what kind of diseases are claimed for monoterpenes in patents? So you can do this easily here. With this graphical user interface, you will see that several diseases are associated to be useful uses for monoterpenes. And then you can go to the sentence where this has been mentioned, and you can find the patent which displays this biological activity. So I hope I could convince you that chemical ontologies may have some use. If anybody wants to use them, we are happy to talk to you, and please take a visit at our webpage and try it out. Thanks.